You know, if you ever get a chance to look closely at a modern airliner, you'll notice its skin is just covered with all these little bumps, fins, and blades. Well, they aren't just for show. They're actually the aircraft's invisible nervous system. And this network? It's every bit as critical as the engines or the wings, connecting the plane to the entire world and guiding it safely through the sky. So how does this whole complex web of antennas actually work? Let's find out.
Really, it all boils down to that one question. Just think about it. You're in a metal tube, flying at nearly the speed of sound, 7 miles above the ground. How on earth do you talk to people below, see what the weather's doing up ahead, and know exactly where you are? Well, the answer is in the incredibly smart, strategic placement of dozens of specialized antennas, each one doing a very specific, very vital job.
So to really understand this, we're going to take a virtual walk-around of a modern airliner. We'll kick things off with the fundamental rules of the radio sky. Then we'll check out the sensory systems packed into the nose, move on to the busy communication hub of the fuselage, and wrap things up at the tail. By the end, you'll see the whole big picture and how it all fits together.
Okay, before we dive into any specific antenna, we have to get our heads around the basic physics and engineering rules of the game. See, there's a really strict set of principles that govern this world of radio waves, and for the engineers, it's a massive balancing act to make it all work perfectly.
This is the heart of the engineering puzzle, right here. You absolutely need a clear line of sight for these signals to work, but at the same time, you have dozens of powerful antennas that you have to keep from interfering with each other. And on top of all that, the whole thing has to be perfectly aerodynamic. A major headache is something called shadowing. Like if an antenna on top is blocked by the tail when the plane banks, you could lose a critical signal. So every single placement is a carefully calculated trade-off.
Now, the most important concept to wrap your head around is line of sight. It's simple, really. For most of these high-frequency systems, the antenna needs a clean, direct, and totally unobstructed path to whatever it's talking to, whether that's a satellite way out in space, a ground station hundreds of miles away, or another plane flying nearby. This one rule pretty much dictates almost every placement decision we're about to see.
All right, let's start our walk around right at the very front of the plane. The nose cone, which is technically called a radome, is home to some of the most critical forward-looking systems. You can think of these as the aircraft's main senses, perceiving everything that lies directly ahead of it.
And the most important forward-looking sense has got to be the weather radar. This thing is like the pilot's superpower. It lets them see right into a storm cell from miles and miles away, painting this detailed picture of rain, turbulence, and other nasty stuff. That allows them to plot a safe course right through or around the bad weather, which means a much smoother ride for everyone on board.
So why the nose? Well, it's pure logic. The radar has this big dish that needs to sweep back and forth, scanning the sky right in front of the plane. So by sticking it inside the nose cone, which is made of a special material that's totally transparent to radio waves, it gets a perfect panoramic forward view without creating any aerodynamic drag. It's the only place it could possibly go.
Also tucked away near the nose are a few smaller, less obvious antennas. These are for the Instrument Landing System, or ILS. And these are absolutely critical for guiding the aircraft down to the runway with incredible precision, especially when pilots can't see a thing because of fog, heavy rain, or really low clouds.
So the ILS works by locking onto two different radio beams sent from the runway. One gives you your horizontal alignment, that's called the localizer, and the other gives you your vertical descent path, the glide slope. To see these beams as early and clearly as possible during that supercritical final approach, the antennas have to be right there at the front of the plane, pointing toward the runway.
Okay, moving back from the nose, we get to the fuselage, the main body of the aircraft. Think of this part as the plane's central hub for all things communication and navigation. It is, without a doubt, the most crowded real estate on the entire plane, just packed with antennas on both the top and the bottom.
First up, let's talk about the aircraft's voices. These are the VHF and HF radio antennas, and they handle all the talking between the pilots and air traffic control. They are the plane's absolute lifeline to the ground, but they serve two very different and equally important jobs. And here's the key difference. VHF gives you crystal clear line-of-sight communication. It's perfect for routine chats with air traffic control when you're flying over land. But once you're over a huge ocean, those signals just can't reach. That's where HF radio comes in. It does this clever trick where it bounces its signal off the Earth's ionosphere, which lets you communicate from anywhere in the world, even if it sometimes sounds a little like a crackly long-distance call from the 70s. Next up are the systems that give the aircraft its truly global reach.
You've got GPS, the Global Positioning System, which tells the plane its exact position anywhere on the planet. And then you have SATCOM, for satellite communication. That provides the broadband data and voice link. Yep, this is the system that brings you that sweet in-flight Wi-Fi you're using to stream movies.
Now, the logic for placing these is pretty simple. They need to see the sky. And the only place on an airplane that guarantees a clear, upward-facing view of all those orbiting satellites, no matter how the plane is turning or banking, is the very top of the fuselage. That's why you'll always find those little GPS antennas and that big SATCOM hump right there on top.
So how does the aircraft see other planes? And for that matter, how does air traffic control see the aircraft? Well, that's the job of the ATC transponder and TCAS, the Traffic Collision Avoidance System. They're constantly shouting out the plane's identity, its altitude, and its heading, while at the same time listening for the signals from all the other aircraft in the sky nearby.
For safety systems this important, total coverage is just non-negotiable. You have to have a complete 360-degree bubble of awareness all around the aircraft. So by putting identical blade antennas on both the top and the bottom of the fuselage, engineers make sure that no matter how the aircraft banks or turns, it never loses contact with ground radar or a nearby plane. The body of the plane itself can't block or shadow the signal.
Now, as the aircraft gets really close to the ground for landing, one very specialized system becomes incredibly important: the radio altimeter. Unlike the regular altimeter that measures your height above sea level, this one tells the pilot the exact, real-time height above the actual ground right below the plane.
Yeah, its entire job is to measure with extreme precision how high the aircraft is above the terrain. And to do that, its antennas are mounted on the belly, pointing straight down. They literally bounce a radio signal off the surface and measure how long it takes to come back. This real-time data is absolutely critical for automated landings and for flying approaches in basically zero visibility weather.
All right, let's head to our final stop on this walk around, the tail. This spot is chosen for a couple of reasons. It's structurally very strong, and it provides a nice, high, clear mounting point that gives a fantastic view of the world for some of the plane's most vital navigation and emergency systems.
So housed in or on the tail, you have two key systems. First is the VOR. That stands for VHF Omnidirectional Range. It's a real workhorse navigation system that lets planes find their way using a huge network of ground-based radio beacons. And then there's the ELT, the Emergency Locator Transmitter. This is the aircraft's last-ditch lifeline if something goes wrong.
And what's interesting is that these two systems are put on the tail for totally different reasons. The VOR antenna sits way up high on the tail fin to get the best possible 360-degree line of sight to those stations on the ground. The ELT, on the other hand, is placed deep inside the tail structure because the tail is one of the strongest parts of the aircraft. This gives that emergency beacon the best possible chance of surviving an impact and automatically sending out a distress signal.
So, when you zoom out and look at the whole aircraft, it becomes so clear that this isn't just a random collection of parts. From the forward-looking radar in the nose, to that comms HUD on the fuselage, and all the way to the emergency beacon in the tail, these antennas form a really complex, redundant, and life-saving network. They are truly the invisible systems that make modern aviation not just possible, but incredibly safe.
And that brings us to one last thought. This whole intricate network, it's evolved over decades to meet the challenges of its time. But now, our skies are getting more and more crowded with drones, with air taxis, with automated aircraft. It really makes you wonder what comes next. What new antennas, what new senses will the airplanes of the future need to navigate our skies even more safely and efficiently?